In this video, let us discuss about the eccentricity of a hyperbola. So, for a standard hyperbola, the value of eccentricity is given by square root of 1 plus b squared by a squared. Now, if you similarly compare this equation with the equation of ellipse, we have x square by a square plus y square by b square is equals to 1. Now, in case of ellipse, eccentricity is given by square root of 1 minus b squared by a squared. Now, as we had discussed earlier, if we replace b square by minus b square, this minus sign becomes plus. And on doing this, we get the values for a hyperbola. So this here represents the eccentricity of ellipse, and this equation gives the value of eccentricity for a hyperbola. So this can also be understood as eccentricity is equal to the ratio of distance of foci from the center to the distance of vertex from the center. Now this is the other way to understand the value of eccentricity, and this can also be written as this is equal to square root of 1 plus conjugate axis upon transverse axis squared. So this is how the value of eccentricity is in case of a hyperbola. In this video, let us talk about the concept of latus rectum of an hyperbola. तो जो latus rectum का फॉर्मूला होता है that remains the same as in case of an ellipse. तो let us say ये हमने transverse axis draw कर लिया, ये conjugate axis हो गया और ये हमारा hyperbola हो गया. So if suppose this is point S and this is point S dash, अगर हम एक लाइन इस तरह से ड्रॉ कर लें passing through both the foci, we get the two latus recta. So we call this one as the latus rectum which is passing through S as L1, L2, and by the other focus, let us call it L3 and L4. Now, since we know the focus has coordinates AE, 0, if we talk about the coordinates of point L1, it can be represented by AE, K. तो अब हम क्या करेंगे, हमारे हाइपरबोला के इक्वेशन में we will put this point and find out the value of k. तो since ये point hyperbola पे lie करता है, if we put it in the standard equation, हमको मिलेगा a square e square by a square minus k square by b square is equals to 1. So clearly a square gets cancelled out, and what we have is e square minus 1 is equals to k square upon b square. Now, since we know in case of hyperbola, eccentricity E is given by under root of 1 plus b square by a square, या फिर अगर हम इसको square कर ले दोनों तरफ, so we have e square is equals to 1 plus b square by a square, and that gives us e square minus 1 is equal to b square by a square. So if we put in the value of e square minus 1 here, we get b square by a square is equals to k square by b square, and that gives us k square is equals to b raised to 4 by a square, and hence the value of k is b squared upon a. तो हमें k की वैल्यू मिल गई. Now, if we go to the next page and try to again draw the diagram, ये हमारा हाइपरबोला है और ये हमारा लैटस रेक्टम है. दिस इज S, दिस इज L1, दिस इज L2. तो अब L1 का कोऑर्डिनेट्स हो जाता है हमारे पास AE, B square by A, and since this graph is symmetric about the x-axis, L2 का coordinates we can write as AE, minus B square by A. Similarly, if we look at the other lattice rectum, the ends are given by L3 and L4, and they will have coordinates minus AE, B squared by A, and L4 will have coordinates minus AE, minus B squared by A. And that brings us to another important point, which is length of lattice rectum. So इसको हम short form में LLR से भी denote करेंगे. So if this distance is B square by A and this is also B square by A, so the total distance is equal to 2B square by A. And this result is same in case of ellipse also. So that is a very important result which is useful in many questions. So you must always try to remember this.